All right, good morning. So welcome back to Calc 2 here. We are going to be talking about improper integrals this morning. Okay, so most of the problems in this chapter are not terribly difficult from a math standpoint. You've done indefinite integrals with this. You've even done definite integrals, but the limit hasn't been like off to infinity and beyond kind of a thing. So in this section, we're going to deal with integrals that you can see like in the background here have an infinity in one of the limits. That's what makes it improper. So skill-wise, you kind of already know this, but there's a way of writing this stuff out that's very particular, and that's what this section is about. Okay, is writing this out in a particular way, so that we're evaluating it correctly, right? So, and this section typically has a lot of issues for a lot of students, only because they don't practice writing it out. The jargon, the lingo, writing out the math doesn't make a lot of sense because you haven't practiced a lot of it yet. And I'll admit, I mean, I sometimes I get it backwards too. So it's something we have to work on as well. Okay, but if we just start, okay, what we have here, okay, we have integral from 2 off to infinity, okay, 5 over x squared dx. Now that's not a hard, if I didn't put the limits in, this is not a hard looking integral. Okay, we're just going to change it to 2 to infinity of 5x to the negative 2 dx. Okay, now I know a lot of the people that you're going to talk to, physics majors or advanced chemistry people, like they're just going to go ahead and do this without worrying about it, and you're not allowed to do that yet. Okay, so this is the class where you learn how to write this stuff out formally. So you guys, it might be nice to share my meeting. That way you guys can see what I'm talking about. Okay, so all I did was rewrite it. Like, as I was saying though, this is where you learn how to write this stuff out. So unfortunately, you have to do it formally too. Okay, so we don't like having infinity in their integral sign. Okay, that's not really a proper thing. That's why it's improper. Okay, so what we're going to do, pick your favorite letter. Okay. So we're going to take the limit as, how about we use a, goes to infinity, right, of the limit of the integral 2 to a of 5x to the negative 2 dx. Okay, that's the hardest part. And you think I'm kidding, but it's really not. This is it. Okay, we replace the infinity, or if there's a discontinuity, we replace that point with a discontinuity, and then we just decided a letter and say, well, the limit is a goes to infinity, and then we evaluate this thing. So go ahead and do that. That's going to be 5x to the negative 1 over negative 1. Okay, that's the integral, and we're going from 2 to a, the limit as a goes to infinity. Okay, so here we have negative 5x to the negative 1 from 2 to a, limit as a goes to infinity. Do you know you're allowed to swap your limits of integration if you have a negative sign, if that will consume your negative sign? So this is the same as it goes off to infinity, 5x to the negative 1 of a to 2. What happened to the negative sign? The negative sign happened by switching my limits of integration. Okay, instead of top 1 minus bottom 1, it's really bottom 1 minus top 1. That's where the negative sign went. So that's a fairly common thing to do in a section like this, because you're going to see a lot of things like that. Okay, a lot of forms like that. And then we can just evaluate for the limits. Okay, evaluate the limits of integration. So this is 5 times 2 to the -1 minus limit as a goes to infinity of 5 times a to the -1. Right? And you guys have done this before, okay, in Calc 1 so long ago, I know. But this is, right, this is 5/2 minus this is 5 over a, and limit as a goes off to infinity, right? What is that limit? Right? As a goes off to infinity, like 1 over x as x goes to infinity, right? You know that that's 0. So this is 5/2 minus 0, 5/2. Okay. What am I looking for when you do your problems? Okay, you can't do this on Pearson. Like my math lab, it will not grade you on this aspect. So I would urge you to write this stuff out this way. Okay, replace the infinity sign or 0. Sometimes it's a 0. It's weird things going on there with your favorite letter. Use the limit as your letter goes to that boundary. Solve the integral as normal, okay, and then whenever you write that letter, you're writing the limit next to it until you're done. Okay, that's how it works. So it doesn't diverge, right? It goes to a value. We're good. So we're just going to say, okay, well, this is 5/2. Okay. So this is 5, 2, 5, 2, and then we're set. So we'll check. Okay, fantastic. All right, let's try one that's a little bit harder. Okay, that looks fine. It's kind of the same problem, similar. Okay, so we are going from negative infinity off to -1. Okay, so here we have here's our stated problem. Negative infinity up to -1. What are we trying to integrate here? We are trying to integrate x to the -16/7. All right. So thankfully, they put it in integral, calculus format already. So what we're going to do is we're going to write limit. And again, what's your favorite letter for this? Okay. Now we go t goes to negative infinity. And we're going to say t off to -1, x to the -16/7 dx. Right? Now we're just going to integrate this normally. Okay, so it's a little bit tricky because, right, we gotta add 1. So -16 plus 7, where's that going to give us? It's going to give us -9. So we're going to have x to the -9/7 over -9/7. Okay? We're going to be going from t to -1, but because we wrote down our t, we have to say what the heck is t, and t is going to negative infinity here, right? So let's go ahead and say this is -7/9, okay? X to the -9/7, going from t to -1, limit as t approaches negative infinity. Every time I have a negative sign, I like to do this with my integrals because if I have a chance of messing it up, this is where it's going to happen. Okay, so in order to reduce the number of stray negative signs I have in my problem, I will generally take this and say, well, this is the limit as t approaches negative infinity of 7/9 x to the -9/7 from -1 to t. Okay, so all we did is we use this negative sign to swap my limits of integration. Right, and now we just plug this in. Okay, so this is 7/9 t to the -9/7 minus 7/9 times -1 to the -9/7. Okay, this is a little bit hard to evaluate, so we're gonna use a little bit of algebra here. So this is there's a 7/9 in those places, isn't there? Okay, we still need to go on there. Okay, So what we're going to have limit as t goes to -9, or negative infinity rather, and this is 1 over t to the 9/7, right? That's what this means, okay? And then minus -1, right, to the 9/7. Well, 9/7, -1 to the 9/7. We're not doing complex numbers. So, like, what's the third root of negative? What's this? All right, that's -1. What's the fifth root of -1? It's -1. Okay. There's ways to get fancier about this. They actually do have like more complex solutions. Complex meaning a plus bi, not that they're hard. In this case, they are though. But we need trig to kind of get the rest of this. So we're not worried about the complex solutions here. We're just worried about the real solutions. So raise -1 to the 9th power, you get -1. Take the 7th root of that, we get -1. So here we are with this, all right? So we have limit of t goes to negative infinity of 7/9. And here we have 0, 0, yeah, we talked about that. Okay. We know that this part here is a -1. Okay. Now, as t goes to negative infinity, right? We have pretty much 1 over x as x goes to infinity, right? This is 0. What happens in the other direction? It's still 0. Okay. What happens if I square it? It's still 0. What happens if we put a 9 here? It's still 0. And we go ahead and do that. It's still 0. So we're going to go ahead and plug in a 9 there. Okay. And then go with that. And then we are set to say this is 7/9. 0 minus a -1, which is 7/9. All right. So the integral converges. It converges to a value of 7/9, and we are set. Okay. So we're going to go ahead and say we have 7/9. Right. Check. Hooray. What do I mean when it diverges? Okay, this could mean it goes to infinity and beyond. Okay, so that is a possibility that a divergent integral goes off to infinity. But when we get to series later, we'll also talk about divergent. It just means it doesn't go anywhere. All right. 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 ... Okay, this sum, right, it alternates between 1 and 0, 1 and 0, 1 and 0. So it never really goes anywhere. It just alternates between these 2 points forever. This also diverges. Because in math, diverge just means it doesn't converge. It doesn't mean that it's going off to infinity. It just means that we don't have a value for it. Okay, so don't saddle yourself with it's divergent means it's going off to infinity or negative infinity. Realize that divergent means like we're not going to be able to write a number down for what this answer is. Okay. Later on, well, actually, we'll do it this way. In trig, this happened more in trig than it happens in your class, just because of the nature of the functions. Trig, there's a function that does this. Okay, so this would be sine, S-I-N-E is sine, and we usually abbreviate it y is equal to S-I-N x. It's not a religious thing, it's this thing, okay? And you can see by the very nature of this function, and then taking a look at this part, right? Instead of going from 1 or 0 and 1 over and over again, it goes from 0 to 1 to 0 to -1 to 0 to 1 to 0 to -1. And if I were to integrate this, right, from 0 to infinity, okay, this is another one where, like, well, depending on where you stop, it's going to give you different values, and you're not allowed to stop. So this would diverge, okay, because we just don't have something for it, okay. It doesn't come back to a number, so it diverges. Even though, no, it's not going off to infinity, it's sticking around between -1 and +1, but we don't have an answer, so there it is. All right, so be careful about that. Let's see here, we did that one. Okay, let's try 7. I'm sorry, there's so many problems in this one. Okay, I really am. A lot of them are pretty easy, and it's the practice of writing this out. Okay, so if we have integral from 0 to infinity, okay, dx over x plus 9 squared dx, or there's dx already. All right, we're going to do two things. We're going to use a u substitution here, right? Because that looks a little scary. And then we got to deal with this, right? Because it's improper integral. Okay, so pick your favorite letter, right? I'm going to say limit, how about theta equals goes to infinity. Okay, 0 up to theta. Okay, and then we have dx over x plus 9. Oops, stop writing that. And we're going to say squared. Let u is equal to x plus 9. Du is equal to dx, right? So here we have it. We have limit as theta goes to infinity, 0 to infinity. And then we have u, right? X plus 9 is now u. So we have u to the -2 du. Dx was du, right? Not a bad integration. So this is limit as theta goes to infinity. Okay, this is -u to the -1. Okay, I really shouldn't have done it this way. I should have written u. Okay, because I changed my limit. I changed my variable, so technically I have to change my limits. Okay, but right now I'm just going to write little subscripts for them so that it's whatever u is at 0 and whatever u is at infinity. Okay, I'm going to change back down, so I don't have to write this. Okay, and again, you will find some calculus teachers that'll take off for not changing your limits of integration here. You won't find many. All right, I generally don't do this. I think there's quite enough to grade you on without going into this. Okay, so unless I'm in a particularly bad mood, you know, I'm not gonna see this. Even if I am in a bad mood, like the day I do it, you can always come back to me. It's like, really, dude? Yeah, I'll take it off. So I'm not interested in penalizing you for doing this, but just realize that that's the proper way to go. All right. So limit theta goes to infinity. You know, we're going to go back to, right? We're back to x plus 9, -1, negative, right? And we're going from 0 to theta, and 0 to infinity. And then I'm going to pull the same thing that we did before. Okay, so this is limit theta goes to infinity, 1 over x plus 9 of theta. Is it to 0? It is to 0. Okay, to 0. Swap my limits of integration. Okay, because the negative sign. So there it went. So let's see here. We have 1 over 0 plus 9 minus limit theta goes to infinity over theta plus 9. Okay, we're evaluating it now. So this is 1/9 minus, well, this is getting bigger and bigger and bigger, right? So 1 over a really big number, 0, 1 over 9 over 7. And again, that is exactly what I'm trying to grade you on, is all of the writing it properly. Okay, so these are fairly easy integrals to do. If we didn't have limits, that's fair, because we're adding an extra level of complexity with this infinity business, right? Let's do one more Okay, before I'll say that maybe we've gone long enough on this video. Actually, let me give you my favorite. I don't know where it is in your homework section, but the one you have to see. Okay, so integral from 0 to infinity of x e to the negative x dx. Okay, so hey, look at this. We've got a polynomial times an exponential. Okay, which means we're going to be setting up for integration by parts. Okay, so let's take care of this first. So this is limit. Again, pick your favorite letter. Let's go with 20. Let's go with E. Goes to infinity. Right? And then we'll integrate from 0 to E. Okay. This is x e to the negative x. Right? But you're coming off of this right after you learn integration by parts. And I know that you're saying, wow, when do I ever get to use this again? All the time. Okay. So we're going to say let u is equal to x, dx du is dx, dv is equal to e to the negative x dx, b is equal to negative e to the negative x. Okay. If I take this derivative, we get back to this, so we're all set. Okay, and then we draw our little box, uv. Okay, so this is limit as e approaches infinity. Okay, so we have uv, so this is negative x e to the negative x minus the integral negative e to the negative x dx uv. Okay, so uv v du. Right. Let's clean this up a little bit. Okay, and again, we're going from 0 to e. Okay, this limit's here, technically 0 to e here. All right, so this is going to be negative x e to the negative x. Actually, let me start a new line. So I have to write my limit. The limit e goes to infinity. Okay, we have negative x e to the negative x. Okay, plus, right? Because it's negative, so we have plus e to the negative x dx. This goes from 0 to e. What is the integral of e to the negative x? Okay, we just did that. That is negative e to the negative x. So we have negative x e to the negative x minus e to the negative x. Okay, and we are going from 0 to e. So now we get to deal with the algebra and the arithmetic, right? Actually, there is one little bit of calculus we're going to have left here, but let me show you what that's going to look like. So we have negative limit e goes to infinity. Okay, I pull out a negative, right? So that is x e to the negative x plus e to the negative x, right? I pulled a negative out of each of these terms, so they swap the sign, right? And then we're going from 0 to e, right? Let's swap the limits of integration. All right? You don't have to do this step. I've noticed there are certain mistakes that I make on a regular basis, and getting rid of this tends to eliminate some of those mistakes. Okay, so that's why I do it this way, and it's just to insulate myself from making the mistakes I normally do. Right? Got rid of the negative sign because we swapped the limits. So yeah, we don't have to. So let's see here. We have effectively, right? We have an infinity over, right? We have x over e to the x here. That's how we could write that. And as let me do the 0 case first. Okay, sorry, I jumped the gun. All right, so as x equals 0, we have 0 times e to the negative 0 plus e to the 0. All right, that's going to be 1 minus limit e goes to infinity. Okay, and then here we have, right, this is another way of writing x e to the negative x is e to the x over x over e to the x. So this is going to be infinity over infinity plus e to the negative infinity, right? That's 0. That's 1 over e to the infinity, right? That's 0. But here, look at this. We have an indeterminate form. What are the odds that we would have put L'Hopital's rule in the section before this section where you would have to deal with indeterminate forms? Okay, so you probably dealt with this integral before, or this limit before, but just to practice L'Hopital's, right? We know that it's indeterminate limit, right? As x goes to infinity. Take the derivative. It's 1 over e to the x. Now, so we can apply L'Hopital's. Okay, so as we apply L'Hopital's here, we end up with 1 over infinity. We get 0. Right? So clear as mud, right? All right. So we have 0 plus 1 minus, what did this thing turn out to be? Right? This limit turned out to be 0, right? Because we applied L'Hopital's rule, we got 0, and then minus 0. It's a lot of zeros, right? There's a very fancy way to say 1, right? But that's what the answer is in something like this. So integral x e to the negative x from 0 to infinity, we know that that is 1. So we did a lot of this in probability when I took probability classes. This is a very, very common thing, very common form for probability. So that's why I make this problem. But it's pretty tame. It showed a lot of things I wanted to show, right, with the L'Hopital's, and we ended up having to deal with improper integrals. So yeah, this is a good one. All right. So yeah, I'm going to go ahead and stop us there with this one. I'll be back in the next video, and we'll finish out some of these problems here. Okay. So let me go ahead and stop, and we'll be right back. All right.